Buenas tardes para todos. Les damos la bienvenida a todas las personas que nos están viendo en estos momentos, aquellas personas que nos están viendo a través de la plataforma Zoom o aquellos que nos ven desde nuestra transmisión en vivo por Facebook Live. Un saludo cordial a todas las personas que estarán viendo la grabación de esta capacitación en nuestro canal de YouTube. Para finalizar nuestro Top Meeting 5, contamos con una charla de gran interés para todos nuestros aliados, de la mano con nuestro aliado Submer, y en su representación Eric Collins, quien nos hablará sobre la refrigeración por inmersión. Eric, so you are very welcome to this meeting. Again, thank you so much for your time. So you can start now. As soon as we get any question or any doubt, I will let you know, okay?
Okay, great. Thank you.
Okay.
So my name is Eric Collins. Let me turn on the video here and get presenting. Why is it not? There it goes. My name is Eric Collins. I'm with Submer. We do immersion cooling. I'll be explaining what that is and see if we can get some video here. There it goes. Okay. So if you have any questions or anything, then just let her know and we'll get it answered for you. I'm based in Houston, Texas. Our headquarters is in Barcelona, Spain. Unfortunately, it is a national holiday in Spain, and we couldn't get someone here that was native Spanish speaker today, but we can certainly follow up with you and get the right resources on the phone or on a call with you. So what does Submer do? Just real quick. So the challenge is data centers are bigger, hotter. We're using about 6% of global energy is going to data center supplies. That's cloud, everything else that we do for data centers. About 6% of global energy is that. It's going to be probably over 20% by 2025. New chips from Intel, AMD, and NVIDIA are all hotter, faster, and demand more electricity. Traditional ways of cooling that, you can't cool it with air anymore, and I'll talk a little bit about that. And this is one of the ways to keep data centers cool as we kind of approach these really intense environments. The other challenge that I think is particularly interesting to your team in Latin America is it's the challenges around controlling IT out at the edge at environments that are harsher and not really meant for technology workloads. I'm going to skip over that one. So what we talk about a lot is we talk about power usage efficiency, or PUE. And the number was originally came out from the Uptime Institute in 2007. They created this method of determining power usage in data centers and how efficient you are. And what it is PUE, or power usage efficiency. It's the ratio of everything that IT is doing, all the computer equipment, and everything to cool and manage that IT equipment. So my switches, servers are on one side of the equation, and on the other side is everything else. Cooling is the biggest factor, lights, infrastructure, anything else. But most of that is cooling and air handling. It's directly related to cooling the data center. So once they created that number, we started to manage to it. And over the next about 8-10 years, or 5 years or so, it quickly got down to this 1.65, basically 1.6, 1.7 range that you see here. And once I got down to this range, that's the limitation of air. I can do things to drive it lower, but it's very difficult and expensive. Most places are a little bit higher than this, but we're kind of stuck at this 1.6, 1.7 range. So for every watt of electricity, I'm using 0.6 watts, 0.6, 0.7 watts to cool it. Or if I'm talking kilowatts, 650 watts to cool every kilowatt. And I'm stuck here. The new numbers for 2020 came out and they were 1.65 again. So we're just kind of stuck. So what do we do? Where do we go from here? What we do is we cool them with fluid. So if I go back to the first slide real quick, this is our lovely head of marketing. she is immersing these servers in fluid. It's dielectric fluid is what it's called. There's two main areas I'll talk about today that we differentiate. One of them is the fluid, and then the other is how we cool the fluid, or what we call a cooling distribution unit. And that's this silver unit back here. So I'll come back to this. But what we do is we take servers, we immerse them in fluid, and I can drive these efficiencies that you see back here. I can drive this from 1.65 to 1.03 very consistently. It went literally 1/20th or 5% of the power I was using to cool the data center. I'm now using just 5% of what it was. I reduced it by 95%. I could do that very consistently. The worst that we've measured in the real world so far was 1.37. So I'm still a 20th of what I would normally be in a air-cooled environment. And we do this with these products, but let me talk real quickly about how it fits into the data center. So a typical data center, I have a rack of equipment down here. I air cool it, and then I cool that air. I move that air around with big computer room air conditioners. If you've been in a data center, over at the side, the big air handlers, and then outside cooling towers that predominantly use evaporated water to cool coils that then cool the fluid that I move through the building to cool the air conditioners. That's expensive. It's not a good use of resources, uses a tremendous amount of water. A typical data center, small, medium-sized data center will go through 2 full-size swimming pools of water every day. I switched that. It's 1 full-size swimming pool every 2 days for a typical small data center. A larger data center, to give you an example, Google was building a data center in North Texas, and they requested from the local utility, the water provider, 1.3 billion gallons of water per year, or 1.3, yeah, it's a lot, 1,300 million. So it's a tremendous amount of water data centers use. What we do, we replace the racks with immersion pods, that first slide I showed you, and then we immerse it. And once I immerse it, I can run at much higher operating temperatures. So this inlet temperature, the blue line, that's my cool water. I'm normally doing that at 90 Fahrenheit, really 95 Fahrenheit, or about 32 Celsius. So I have an inlet temperature of 32 Celsius. Compare that to a normal data center around 17, 15 degrees Celsius. And then my outlet water temperature of my normal fluid loop is going to be about 105, which is about 37 Celsius. So once I do that, now I'm at temperatures that I can air cool this most of the year. Any day that it's below, that my ambient temperature is below 105 degrees or 37 Celsius, I can take advantage of air cooling. I don't use any water. Excuse me. And these units for air cooling are very efficient, because I'm only trying to take water that's 105 degrees or 37 Celsius, and I'm only trying to reduce it down to 32 Celsius. So that's much higher temperatures. The computer equipment runs quite nicely at these temperatures because I stay in this heat range the whole time. I never really go much over that. It might go up to 38, 39 Celsius, but we never by design hit 45, for example, or anything near that. We can, computer equipment will run fine at that, but it's just not necessary. So then once I do that, I have these loops here. The only thing that I'm doing that uses electricity here is the 2 pumps to move the fluid through the loop. And this is a normal water glycol data center mix. If you're in an environment that's warmer where freezing is not a risk, then I would just run all water, or water with a little bit of glycol to make it work nicely. Very efficient cooling medium. And then just the fans to move the air across the coils, across the heat exchanger. And that is extremely efficient. I don't have computer room air conditioner. I don't have compression. I don't use any kind of hydrofluorocarbons like Freon or any CFCs to compress. I'm not doing any kind of compression cooling for this loop, for this environment. And once I do that, that's where we're driving all those efficiencies from. Now, I'll pause here for a minute. I'm going to talk next about the CDU, but let me pause here and make sure that there's no questions, or if there are questions, let me just pause here for questions.
¿Alguno tiene una pregunta hasta acá? No, Eric, there are no questions so far.
Okay, great. Thank you. So let's talk for a second about the CDU. So now I'm doing my heat exchange in this cooling distribution unit. Now, something we do that's a little bit different in this space, we do not let our fluid leave the tank. The fluid stays in the tank the whole time. And I can hot swap these units here. That's that silver unit you saw on the very first slide. Let me jump back to it real quick. That's this unit right here, the cooling distribution unit. So inside of there is my heat exchanger, my pumps, all the intelligence for the system is all in this unit right here. And there's one of these at each end, typically, and that's where I'm doing my heat exchange. So our fluid stays inside the tank locally the whole time. And then let's talk for a second about the fluid itself. I'd say there was two main areas we innovate on. One is the CDU, the other one's the coolant itself. So our coolant, a lot of the fluids that are on the market are a modified mineral oil. Ours is not. Ours is our own formulation. It's a synthetic fluid. It's compatible with anything. Lifespan is expected to be full lifespan of a data center about 15 years. It gives you a degree of thermal uniformity. I mentioned that earlier, but what I don't get, like in an air-cooled environment, the temperatures of the equipment itself will swing a good 10 to 20 degrees centigrade very routinely. Memory, CPUs, they get busy, they get hot, fans speed up, they slow down. I don't do that in this environment. In this environment, I'm going to just stay within about 5 degrees centigrade, no matter how much work the systems are doing. So there's this thermal uniformity that makes everything a little bit more reliable, but it also really extends the life of the equipment. I also remove the moving parts to get a server ready for immersion. I'll talk about that in a second. Our fluid is also non-toxic. It's certified biodegradable, and you can actually drink it. I have drank it a couple of times. No lingering effects, but it's not the best tasting thing ever, but it's not horrible. It's just not any good. But you can drink it. It's considered a food grade lubricant. And something that may matter too is when you're going into a harsher environment, we can seal it from the environment, but then the fluid also actually adds an additional layer of protection. One area that there was some interest around was mining applications. Let me jump back here and talk about the product family now. So the three products you see on the left, these are for data centers. They're just the same thing, two different sizes and two different levels of cooling. So 50 kilowatts of cooling capacity, 100 kilowatts of cooling in a regular 42U rack, and then 50 kilowatts of cooling in a half rack. So this is used a lot for demos or for very point solutions like AI machine learning or research, things like that. That's what the SmartPod X is for. And these others are the more traditional IT environments, data centers and things. Now this one, I say it's EU only, but that's really because of the power certification. It's designed around 220. There is a UL listed version of this that would be 110. But within this framework here, I take what was, if I go back to, oh, wrong way. If I go to this slide where this is my cooler and this is my pod, I take all that and I integrate it into one unit. So I've got 6U of server space over here, and then an integrated cooler on the left-hand side of it that does all the cooling for the equipment. So let me pause here. I talked about the product family, and then another product that's also getting a lot of traction. Oops, I went too far. This is the Megapod. So basically an entire self-contained data center, my power distribution, the pods themselves, fire suppression, air coolers on top to run everything, a complete turnkey 400 kilowatt data center. And this thing ships as just 2 units. It ships as a container here, and then we ship the air cooler. So I could put these in any kind of environment, edge of network, really anything. We're putting these in New York where it's difficult to get building permits. We're putting there's some military applications for this where they look at this for a data center in a harsh environment, deserts. In the Middle East, Dubai is getting some of these to put data centers in desert location. What else? Those are the main applications for it. Anywhere it's hard to build, you want to build a data center quickly, or the environment's too harsh for a normal data center, you would take a look at something like this. So I've talked about the product family, the fluid, and the cooling distribution unit. Are there any questions?
¿Tienen alguna pregunta sobre la familia de partes, sobre cómo es la distribución o sobre los fluidos que se manejan? No, Eric, everything is clear.
Okay, great. Thank you very much. Let's see. Talked about the fluid, so let's talk about how to immerse something and what I have to do. How do I prepare a server for immersion? I do a few basic things. I replace the thermal grease that's under the CPUs with indium foil. It's a type of heat transfer foil. I replace that. I disable the fans and remove any fans that are in it. Anything like plastic air baffles, I don't need those, so I take those out. And then I cancel or ignore any fan alerts in the BIOS so that I don't have any alerts because I took the fans out. I don't need to alert that there's no fans in it. I know that. And then it's ready for immersion. That's really all I do. The kinds of things I can immerse, we've immersed every server vendor out there: Gigabyte, HPE, Dell, Lenovo, Supermicro, ASA, Intel, AMD, NVIDIA. Really any kind of server, we've immersed it. We started last year, there were 8 server vendors we worked with, or I'm sorry, 6. And now we're working with over 40 major manufacturers on anything that they have interest in managing the heat for it. Any kind of solid state storage, so SSD drives are just fine. And any kind of helium spinning media, if it's air-cooled non-helium spinning drives, I can't use those. Those have a little weep hole in them and the fluid will get into the hole and mess the drive up. But a helium drive is sealed. I can use those in any kind of SSD drive. We can do network switches. I can do any kind of copper connection, any kind of copper network connection, or single mode fiber. I cannot currently do multi-mode fiber. But for multi-mode fiber, like high-speed InfiniBand, OmniPath, or 100 and 200 gig Ethernet, those are typically multi-mode fiber. And for those, I use an adapter that's a 25 centimeter adapter, and that brings it out of the fluid, and then I take the connection wherever it goes. Power supplies, battery backups, we're testing a number of different UPSs. There are some things around UPSs, but they all work. Power distribution, if I want to do it in the rack, I can do it. Really anything else, anything that you would plug in, I can immerse it. Whether or not it makes sense, then we just help you figure that out. And that's really kind of it. The company was founded in 2014. This is our 4th generation product. And that's it really. Any questions or anything?
¿Alguno tiene alguna pregunta? ¿Alguna inquietud?
Por el momento no, gracias.
All right. Eric, thank you so much for your time and for all the information. We really appreciate it. That is so important for us because this is a new technology and we hope to introduce that technology in Colombia, so we appreciate your help, okay?
Oh, absolutely. Sure.
Thank you so much.
Thank you very much, and glad to have you guys as a partner. I really appreciate it.
Okay, Eric, we hope so. We hope the same. So have a good one and have a good rest of your day, okay?
You too. Everybody have a good weekend, and thank you for attending today.
Okay, thank you so much, Eric. Bueno, entonces agradecemos a todos los que han participado en esta y las demás charlas a través de estos 4 días de capacitación. Para comodidad de todos nuestros aliados, estaremos cargando esta charla subtitulada en español para poderla volver a disfrutar. Con esto cerramos nuestro Top Meeting 5, no sin antes invitarlos a programarse para el siguiente a realizarse el próximo año. Les estaremos enviando toda la información por medio de nuestras redes sociales, Facebook, Instagram y LinkedIn. Y también los invitamos a seguirnos en nuestro canal de YouTube Top Drive SAS, donde han quedado guardados todos los videos de todas las conferencias realizadas. Mil gracias y feliz tarde para todos. Hasta una próxima ocasión.